Earlier we had a program that had a sequence controlled by time. Sometimes we want a sequence controlled by events. We can have a program that will step through a series of sections and it has to finish one before it starts the next. When it is completed, it will reset itself so it is ready to start again. In our example here, the machine will be sitting and waiting for the operator to start the machine. When the operator pushes the start button, a variable that we will call cycle will be turned on. That is the signal to start the section 1 of the program. When that completes, we will turn on a variable that we will call section 1 fin. That is the signal to start the section 2 of the program. When that completes, we will turn on a variable that we'll call section 2 fin. That is the signal to start the finished section of the program. When that completes, we will turn on a variable that we'll call finish. The machine will go through the reset machine section where all the variables are reset and the outputs will be switched off. The machine will stop and be ready to restart. When the stop button is pressed, a reset machine section will be completed so the machine will stop and be ready to restart. To make our program simpler, we will have the section 1, section 2 and the reset machine as subroutines. We don't want a section to be run unless we call for it. Here is another way of looking at what we are trying to achieve. When we press the start button, the variable cycle comes on. This is the signal to start section 1 subroutine. We want to run section 1 subroutine until the variable section 1 fin comes on. Then we want to stop running section 1 subroutine. We can write a sentence. Call section 1 if cycle is on and section 1 fin is not on. When section 1 is finished, the gate will prevent the subroutine from running again. When section 1 finishes, we want section 2 to start. Section 2 will run and then the section 2 fin variable will turn on. We can write a sentence. Call section 2 if cycle is on and section 1 fin is on and section 2 fin is not on. When section 2 finishes and the rest of the program finishes, we want to clear all the variables in the clear subroutine to reset the machine, and then the program is ready to restart. With ladder, you can use negated coil to switch off the variables. With function block, you can use the move function to move 0 to the variables. The order in which elements of the program are executed until now has not been important, but there are cases where the order of the program is very important. From the previous example, when the second section completes, we want the program to stop. That is, switch off cycle and also reset all the variables. With this program layout, the clear subroutine is run, which will reset the variable section 2 fin. If the variable section 2 fin is off, then the variable cycle will stay on and the program won't stop. The program cycle will repeat and the program will restart. With this program layout, cycle is first turned off because the variable section 2 fin is on. Then the clear subroutine is run and all the variables will be reset. The program is ready for the start button to be pressed. Write a sequence program. Refer to section 34.5 in the PLC notes. We can use the program developed in the previous video. The operator start consists of start and stop buttons. When the program is started, sequence 1 will start. Sequence 1 will have two outputs, where from 0 to 5 seconds output 1 is on, and 5 to 10 seconds all outputs are off. Output 2 is on from 10 to 15 seconds, and all outputs are off from 15 to 20 seconds. The cycle then repeats. Sequence 2 will have two outputs, where from 0 to 5 seconds output 3 is on, and from 5 to 10 seconds all outputs are off. Output 4 is on from 10 to 15 seconds, and all outputs are off from 15 to 20 seconds. The cycle then repeats. When the cycle's complete, the program will stop, clear all variables, and be ready to start again. If the stop button is pushed at any time, the cycle will stop and all the outputs will be off, and the program will be ready to start again. Use the exercise 5 screen to test the program. The next slide has some tips on using counters in subroutines. In the previous exercise, you may find that the program goes through once, but it won't reset and start again. You'll find that the cause is the counter not being reset. Here are two solutions. Create a reset that is on for long enough to reset the counter and then go off. Before cycle turns on, reset 1 is on. Cycle will turn on and section 1 start will turn on and the subroutine will start. The reset 1 will reset the counter. The input to the off timer will go off and the reset 1 will go off 50 milliseconds later. The counter will be reset and ready to start counting again. Here is the same solution using function block diagram. With this solution, the subroutine is called from the main program. As the subroutine runs, the counter will count up. The new variable fin1 will come on. The rest of the subroutine cycles through. The AND is encountered and the variable section1 fin will turn on and then the counter will reset. The subroutine will cycle through and the AND in the main program will prevent the subroutine from being called again. The rest of the program will continue. The counter is left in a condition so that it can start counting again. With this solution, the location of the section 1 fin before the counter is important. Here is the latter version. If the first line was moved to below the counter, then the section 1 fin would come on and then cause the subroutine to end and so not reset the counter.